I have a programming technique that will simplify your code, make it more efficient, and make your life 10 times easier. In this video, I'll show you exactly what the issue is, meaning how a lot of people structure their code, and I'll show you exactly how you can do it way better and structure your code like a professional. What I'm about to show you will be in the context of TypeScript, but this idea should apply to most other modern programming languages. Let me know if this scenario sounds familiar. You have a function, for example, one called doSomething. And in this function, we have a parameter that, for the sake of this example, is an object called user. And let's say this function is used in two spots in our app. One spot where this object always needs to be defined, and another spot where it only needs to be defined sometimes. Therefore, we need to make this argument optional. In other words, this parameter could be of type user, but it could also be undefined. At the start of our function, we're trying to extract name and email from the object, and then make a post request with it, and then just return whatever response that we get. TypeScript gets mad right here and says, hey, we can't extract name and email because user's possibly undefined. And if you try and extract that from undefined, it's going to crash your app, which is not good. So your first brilliant thought is, I know exactly how to silence this error and be safe. Let's just wrap all this code in a giant if statement. Let's just say if user is defined, then let's have some code chunk here. Let's take all the code that we have, and let's just go ahead and stick it inside of here. And now it'll be safe and eliminate the type error. This is valid to some extent, and it's a very common way of doing things, but I have a much better way. Instead of saying if this argument is valid, do something, I want you to do the exact opposite. If this argument is not valid, let's do nothing. And what do I mean by that? In this scenario, it would mean getting rid of this if statement altogether, so just deleting this, and instead of saying if user, all we're going to say is if not user, return, save it, and look at that. We flattened our code out completely, removing the need for any nested if statements while effectively doing the exact same thing. We're saying that if we get into this function and for some reason user is undefined, just return from this function and don't even try to execute anything else. Now if we want to extract properties out of user down here and make a post request, it will always be valid because user can never be undefined if we've made it past this if statement. This is known as the guard clause because we're guarding our function from ever trying to perform operations in an unsafe state, and we're doing so in an extremely clean and effective way. What the guard clause does to all your functions is makes it so that once you get past the conditions at the top, you know you're in the clear. If you eliminate all the bad conditions at the top of the function, by the time you're at the bottom of the function, only the good conditions are left. A great way to think about it is a logic gate right when we get into any function. Functions can be super flexible, but sometimes to make functions flexible, you have to scan the code to find spots that need safety and start nesting conditionals to ensure everything goes smoothly. A guard clause acts as a barrier of safety to every function. At the beginning of the function, if we have any condition that might cause the function to not work correctly or at the right time, we shut it down right there before anything can continue. Think of it like bouncers at a bar. Imagine if bouncers in security let every single person into a bar, but then once they got in, they have to dig through the crowd and find all underage people and then kick them out. That's the equivalent to having a function that allows any argument in, but then inside the function we have one or more conditions that simply avoid all the bad cases. If you look at it in this light, it just doesn't make that much sense. Instead, it makes way more sense to allow anyone to come up to the entrance of the bar. The bouncers let valid people in, but as soon as they see someone who doesn't meet the criteria, like being underage, they stop them from even entering in the first place. Guard clauses are our bouncers. If we stop every invalid condition from getting to enter the main body of our function, then that means the only remaining conditions are the valid ones, meaning everybody in the bar, i.e. everything in the function, is valid. If you get rid of all the bad cases at the start, you don't have to worry later on about doing anything unsafe. And if you do happen to find another case that should cause the function to stop, just add it to the guard. The reason why this practice of utilizing the guard clause might seem somewhat foreign to you is because traditionally in languages like C, it was heavily encouraged that you have one return at the very end of the function, or else you were just writing sloppy code. That's what I was taught when learning how to code, and the same for many other people. With modern programming languages, this is not the case. Utilizing an early return is perfectly valid and very efficient if used correctly. Let me show you another very basic example. Here we have a function called average_top3, and it takes in an array as a parameter called nums that is not optional or anything, meaning it has to be defined. This function sorts the top 3 and only the top 3. So our initial thought is, okay, let's just say if nums.length is greater than or equal to 3, then we're good to go and we can run this code. And then we have this fallback else case where we just console out an error and then return null. And this works fine, but this requires us while we're writing our logic to think, hey, we need to nest this inside of this here, and then have this fallback case if that didn't work. And even though this example is super simple, that's not the most efficient way we could write our logic. What we can do instead is use the guard clause and check where the condition isn't greater than or equal to 3. So instead of checking if nums.length is greater than or equal to 3, what we should say instead is if nums.length is less than 3, then we can make this a code bracket here and take this code right here. And then we can just get rid of this if else at the bottom entirely, just like this, save it, and now our code is the exact same thing. This flattens out our code and simplifies the logical flow of things. If the length is less than 3, we simply log out the error and return. Otherwise, if we get past it, meaning we're in this chunk of code down here, we know we're in a valid state. Now that you have a basic understanding of some simple examples, let's step up the complexity of these guards a little bit and you'll start to see where this becomes more useful. Here I have a super ugly function called update user profile that just takes in a user that can be of type user profile or null. And what this function is essentially doing is checking if each field of user being user profile is valid, and if not, we log out exactly what the issue is. We have like 5 layers of nested if statements here, and your first thought is probably, well, why don't we just combine them into one if statement? And it's because if we're checking the logical truth of things, meaning checking if certain conditions are true, like if this trim is not empty string, if this email has an @ sign, if the user is older than 18, and so forth, then we have to have a fallback case for every single one, which is what spawns all these else statements here and creates this really ugly looking tree structure. Now, in all honesty, if your code ever got to this point, you're probably doing something wrong, but for the sake of this case, just know that we have these fallbacks to know exactly where the problem is. And this level of nesting is just a bit absurd, it looks really bad, and it's not easy to follow at all. I have a much simpler solution that does the exact same thing. I've taken every single condition that we just had, moved it to the very top of the function, and given each condition its own check. And instead of checking if each thing is valid, we instead check if each thing is invalid. If the user is null, for example, we log that out and then return. If the trim is equal to an empty string, we log that out and then return. We go through all these checks at the very beginning of the function so that by the time we get to the very bottom, where we're logging this out, we know that if we get to this console log, that everything is valid and where it should be. We know we've reached a point of safety, so we can perform whatever functionality we would like. We just went from 5 nested layers of if statements, an ugly looking code structure that you can't read, to 5 conditions that are not layered at all, are actually readable, and are logically structured in such a way that if we hit them, we can just jump out of our function entirely. Now, by this point in the video, you may be wondering, what if it's not just one condition that needs to be met for our function to execute properly? What if it is a joint condition, like in this example, we're saying if user is not equal to null, and the title.trim is not equal to an empty string, and the length is greater than or equal to 100. Only if all 3 of these cases are met can we actually do something, and then we have this fallback case if for some reason one of them is false. Remember that to do a guard clause, we need to perform the logical opposite of what we would be if it were structured like this. With joint conditions like this one, that would require us to do 2 things. First, identify any AND conditions that require multiple conditions to be true. And by AND conditions, I'm referring to these ampersands right here. You want to change these AND conditions to OR conditions because OR is the logical opposite of AND. And next, you'll want to flip each condition itself. So we have 3 conditions. The first one being if user is not equal to null. So instead of doing that, we want to check if it is equal to null. The next condition is if the trim is not equal to an empty string. So we're going to do the same thing there. This will be actually if it is an empty string. And the opposite of this condition right here, checking if it's greater than or equal to 100, is just checking if it is less than 100. So we have just completely inverted our logic. And what we can do here is take this console error right here. Let's put this in our if statement, and then we're going to return. We can take this, which means we were successful, delete all of this entirely, put it down here, save, and now we've just done a guard clause successfully. The distinction here is that when we have our conditions set up like this, we're saying in order for this code to run, every single one of these has to be true. In the case with the guard clause like we have now, we're essentially doing the exact same thing with opposite logic. If a single one of these conditions returns true, like this returns true, or this returns true, or this returns true, that implies that not every single condition was valid and met properly, so we need to just return from this function. However, if we make it past this chunk and we get to this console log down here, that implies that every condition is valid. So whether or not we're using a guard clause, this code can only run if every condition is valid. The difference with the guard clause is that we don't have to worry about nested if-else statements, and we don't let the logic even make it to the main body of the function. I want to make a very important note here. I mentioned that if you're trying to change an if-else into a guard clause, you need to change the and conditions to or conditions. Don't just apply this blindly though, because it depends on how your conditions are set up. Very generally, if I have a conditional setup like this, where I say if, condition 1 and condition 2, and condition 3 like this, the logical opposite is going to be if not this, not this, not this, and then these are all going to be ors instead of ands. That is the logical opposite of what we just had. So when I'm saying change the ands to ors, I'm referring to the ones that are separating out each condition. So these are separating conditions 1 and 2, and these are separating out conditions 2 and 3. So these are the ones that you're going to want to convert into the ors. If maybe inside of condition 2, there were more AND operators because maybe it's a bit more complex, I'm not saying you need to change every single one of those. The main ones you need to change are the ones that separate out each condition, like these. And before we go on, I want to mention that so far, we've simply returned in our guard clause, like how we're doing right here, to just stop execution of the function that we're in. However, depending on the context of your program, you may want to do more than just return. It's entirely possible that if one of your conditions isn't met, that means something is seriously wrong, and instead of just returning, you actually want to throw an error or something, in which case you could easily replace this return here with something like throw new error with whatever error message you want. It's up to you to decide how you want to handle this case. And we could even try wrapping this whole thing in a try catch block and doing this logic here, and then catching an error like this or doing something like that, and then throwing the error and handling it here. Again, it's up to you. The reason I'm using return to show you all this is simply because that's the simplest way to do it, and it's really easy to show. But if you need to throw an error or do something else in this scenario, by all means, feel free to do so. Now that I've talked about the guard clause from a very general programming perspective, I want to apply this to a real scenario. On this channel, we primarily work in the context of React, so I'm going to show you some examples in React, but honestly, these next examples could apply for other web development frameworks as well. The main case where I find this guard clause and early return very important and useful is event handler functions. Here's a fairly straightforward example. We have this pricing form component right here. All it is on this page is a select field where we can select some different fruit options. The default option before anything is clicked is just an empty string. As you can see with this pricing map here, we have an associated price with each fruit option. In our select, every single time it changes, we are calling this handle item change function, which is this function right here. All that we are doing right now is simply getting the ID from e.target.value, and then we're setting some state based on that. At first glance, this looks like it might be valid, but notice something here. Pineapple is actually one of our options in our select, but it's not in our pricing map. So maybe for some reason we still want to allow pineapple to be selected, but we just don't want to calculate a price or anything for it. That's going to be a problem with the way we have this handle item change set up right now, because when we try to set calculated price like this, we are trying to access the ID in pricing map, and pineapple is not in the pricing map. And like I said, the default value is an empty string before anything is clicked, and that is also not in the pricing map. That means the calculated price has a chance of being set to undefined, which could very well mess up the logic of this component. So to effectively stop this, we can do something pretty easy. Right after we capture the item ID, we can make a guard clause here, and we can just say if, and we'll do not item ID or not item ID in pricing map return. And this right here would be our simple guard clause. Empty string should return always, so we want to return on this condition. And we also want to return if the ID that we grabbed is not in the pricing map, for example, pineapple. If we have an item ID and the item ID is in the pricing map, only then can we get to the state down here. And if I now save it and go over here and try and select some fruits that are valid, like apples, you can see here we got a price of $150, which matches the price in the pricing map. Also, bananas works fine, and so does orange. And just like I mentioned before, depending on the context, we might want to do more than simply return. In our case, one potential problem right now is that if we have a valid fruit selected like orange, you can see we have this price of 120. And if I go here and I click pineapple, it's still going to be 120 because we didn't actually get to set the state. So it's going to be the same as what it was before. So instead of just returning and maintaining the state that we had previously, it would be smart in this case to make this an actual code chunk here. And instead of just returning, what we probably should do is have a return at the bottom of this. But above that, we can actually set our states to both null. So let's set selected item to null. And we will also set the calculated price to null as well. And again, that is fine because both of these states support being null. Now we should be good to go. If I go ahead and save this logic, let's just refresh this page for good measure. I select apple here, we have price 150. I select banana, 90, orange is 120. And if I select pineapple again, you can see the price goes away because we have set the calculated price and the item ID both to null, so it resets the state. And if we go back to a valid fruit, it is still good. This is a very practical example in React, especially if your event handlers need to be very flexible and handle a variety of different conditions. If certain conditions are not met, we simply guard against it, stop the execution of the function, and handle state accordingly depending on the context. Here is another example. This example is a form where users are able to submit some feedback in this simple text area right here. We assume there are two types of users for this program. What we just call a user, which is a regular user, or an admin. But whether you're a user or an admin, we call the same handle submit function whenever the submit button is clicked. In practice, you could separate the functions that were called depending on whether you're a user or an admin, but let's just say in this case we want to call the same handler function, but just have some conditions that control the flow. The primary difference between users and admins in this case is that admins are able to check this urgent box right here. So right now I am logged in as an admin, so I have this box available to me. If I were a regular user, I would not have this as an option. So in our handle submit function, at the very top of it, we have our first basic guard clause right here. All it is doing is just checking the feedback to make sure it is not empty. So I can't submit a form if my text box has nothing in it. There are tons of ways to do form validation nowadays, but having a basic guard clause at the very top of your form submit function like this is an easy way to make sure you don't submit the form with invalid conditions. Assuming we've made it past the guard clause, we can now say, by console logging, that we are submitting our feedback for this particular user. And this console log right here, this basic submission that we're trying to mimic, should happen regardless of whether you're a user or an admin. But this is as far as the function should go if you're a user. If you're not an admin, it needs to stop there and not do anything else down here. So we have a guard clause right here to mimic exactly that. We check to see if the user is not an admin. If they are not an admin, we log that out and we return, jumping out of this function before it can even go any farther. But let's say in this case that an admin submitting some feedback that's not marked as urgent is treated in the exact same way that it would be if we're a regular user. So what we can actually do is go to this condition right here, where we're checking if urgent and then logging that out. We could actually just get rid of that and just say if they're not an admin or the message isn't urgent, which should just be not is urgent, then we can return right here. And we just added another guard to our guard clause. Now below this guard clause, if we've made it down here to this console log, we know that we're an admin and we know the message is urgent. So we can go ahead and perform whatever functionality we need to if a message is urgent. For now, we're just logging it out, but we could say, await fetch or do something like that. Just some extra functionality now that we know we're in a valid state. And this is another example of an event handler function that can utilize guard clauses to ensure that we only perform the operations that we actually want to, while guarding against the operations that we don't, like checking if they're not an admin or it's not urgent. And as I said before, guard clauses will become increasingly useful the more complex your app gets. One case where I have found guard clauses to be extremely helpful is in useEffects. The reason being, useEffects run whenever the dependency array changes, but no matter what, it also runs right when the component first mounts, regardless of what its dependencies are. If you've been using React for a while, you know that this is kind of an annoying quirk of using useEffects, especially if you have some asynchronous stuff going on, for example in this code right here. We have a query in this component, meaning we're hitting some backend endpoint when this component first mounts. And we've also got some state to see if the query is in the middle of fetching, meaning this is loading will be true if it is still fetching. We then have a useEffect down here that takes the results of this query, which has a preferred theme on it, like light mode or dark mode, and then sets the data theme of our document to be whatever comes back from that query. Now, I generally be careful about setting document properties like this inside of a use effect, but I think you get the picture. The issue with this code right now, and actually why we have a type error right here, is because whenever the component first mounts, this user profile is not going to be defined right away. It's asynchronous because we have to fetch some data from the backend. So this use effect is going to run before user profile is even defined. And that might introduce some weird problems when we try to set the theme of the document to something that is completely undefined. The easiest solution is usually, whenever we can, to guard our use effects with a guard clause to prevent stuff like this from happening. So at the very top of our use effect, I can do that very simply by writing something like if we're currently in a loading state or user profile doesn't exist yet and it's undefined, then we just return. And that will actually solve our problem and get rid of our type errors. And that's because if either of these conditions return true here, that means that we're not actually ready yet to run the code inside the use effect. So we need to guard against it. If you have use effects in your app like this, you need to make sure that you're actively thinking about what will happen on the first render. Is the stuff that's being manipulated or accessed in your use effect actually going to be defined right away? If not, you should always protect it with a guard clause. If I'm thinking about the logical flow of things in this component first mounts, it's going to hit this query, which is asynchronous, so that's going to be loading when this first hits. So this is going to run before this is even defined, which means we hit the guard clause and we exit out. Then this is going to eventually resolve, cause our component to re-render because user profile has changed. That will trigger the use effect again, and now it will be defined so it can make it past this guard clause and get to this code down here, and now we're in the clear. Guarding against weird first render behavior is very important, but you should also be wary about subsequent re-renders and making sure that you're only running functionality that you want to be running when the dependencies change. For example, let's say in our use user profiles hook where we're actually making this query, that I just change this preferred theme to actually be optional instead of required. Now if we go in here, we're going to have a type error because preferred theme can be light or dark or undefined. So we can add another thing on our guard here saying, okay, or if the user profile dot preferred theme doesn't exist, then we can return as well. What's really nice about using TypeScript with React is that generally you're going to notice these because there will be type errors like this if we don't have all the proper cases covered. So a lot of time you will be able to tell based on the type errors if something should be in your guard clause. However, you always have to keep in mind that TypeScript is not all-knowing, and it's up to you to be actively thinking about what things should be in your guard and what you want to actually happen when your use effect runs. And now that we've gone over a bunch of examples where the guard clause is super helpful, I'm going to go ahead and end this video here. The guard clause is something that I haven't been using a ton up until recently, but I've noticed that it's helped so much with simplifying my conditions and functions and ensuring that I'm being safe and efficient when writing code. And after watching this video through, I hope that you'll be able to apply it and have the same effect with it. Take care everyone, and I'll see you in the next one.